Hello, good morning and welcome to Clever Cracker News. The weather this morning in East Anglia, it is quite chilly, 285 Kelvin. We're going to go a bit warmer, go to London, sunny there, the sun is biting through the clouds, it is quite nice. North Norfolk, it's very rainy, but great for ducks. If you go more to the centre of the country, light going through the clouds, but it's a bit overcast. Now if you go to Wales, there's sheep there. If you go further into Scotland, there is a lot of snow. Hagrid's beard is white now, you're mistaken for Father Christmas. Very cold there. Now if we move on to the sea, the ocean, it is raining and there's lightning, it's very wet there, but as the sea is already quite wet, I think it's just advice from Clever Cracker Weather. If you're going out to the ocean or sea today, bring an umbrella.
That's it from Clever Cracker Weather.
Okay, thank you. So satellites.
Yes, so you did them in GCSE really, but now we're going to apply our Kepler's third law to them and talk a little bit more about them.
Yeah, so Kepler's third law, as we mentioned before, you haven't seen the video on Kepler's third law, look at that. So it basically is talking about t squared being directly proportional to 1 cubed.
Yeah. So the overall equation we got in the last video, we're not going to do it again, is t squared is equal to 4 pi squared over gm,
Yeah,
lots of r cubed.
because that would be a constant there. So using this you can apply it to satellites and bodies. We have to know a bit more about satellites. So there's two main types of satellites that we use.
Yeah. There's low orbit and then there's geostationary.
So geostationary are always along the equator.
Yeah.
That's something you have to know, and that it takes 24 hours to go around the Earth once, so it stays in the same position of the planet.
Yeah. So the result of that is you can look out there and you can just keep watching the satellite forever.
Yeah, and they use that for telecommunication and stuff like that.
Yeah, you've got a constant signal.
Mhm.
You know, you can keep your aerial in a fixed position rather than tracking it across the sky.
Yeah,
It's really useful.
Very useful in that
TV
way.
and stuff.
but it's quite far away.
It is. It's quite expensive to get out there.
Yeah,
And they've got to be moving quite quickly because the Earth's rotating actually really quickly.
yeah.
And you're further out, so you'd have to be rotating even
Even
more
faster,
quickly
yeah.
to keep it at the same position.
So for other things like weather and satellite imaging, we have low satellites.
Now they can orbit the Earth several times in a day.
Yeah, and they can go across any sort of axis as well. It doesn't have to be the equator or anything like that.
Yeah, because the geostationary has to be about the equator.
Yeah.
Obviously they're closer to Earth, so
Mhm.
more high definition pictures and stuff for mapping
Yeah.
and spying.
It's much clearer, and since they're able to do that, they're able to see the effect of urban expansion and ice cap melting and all that side of things, really.
They can see quite a lot of the Earth in a day. You could, I think there's one of them several that could map the entire Earth once in a day.
Yeah, and I had an exam question actually
Yeah.
saying, will it? And you had to work out what area it would cover.
Yeah. So you use this equation.
Mm-hmm.
You can, if you know how far it is away,
Yeah.
you know the mass of Earth.
Yeah.
This is going to be constant. You know the radius. You can find out the period of this satellite.
Yeah.
Hence how many times it will go around in 24 hours.
And then how much of the Earth there is to cover and how much it will cover.
Yeah. And so it's all about applying this formula to
Yeah.
different types of satellites.
And that's pretty much the satellite bit.
Yeah. Useful for weather.
Oh yes, that explains the new. We're going to start a news thing.
Yeah, we love news.
News is good.
And that's satellites in a nutshell. Quite a short video.
Go on, short video, yeah.
Mostly a revision of GCSE with this new equation. There you go.
So there we are.
See you at the next one. Well, so when's it going to rain?
In the sea.